The mean is one of three commonly used measures of average, the others being the mode and the median. Finding the mean is usually quite simple. You have to add up all of the values of the data that you have, then you divide that by the number of data items that you've added up in the first place. So you get the mean is equal to the total of all the values divided by the number of the values. Let's look at an example to see how that works in practice. So we've got a set of test scores here by a class of students, and we want to find out their average. In this sense, we want to find the mean. So here they are. There's a load of scores, and if we count them, we'll find that there are 30 individual scores, which is quite typical from a class of students. So the solution is we want the mean, and the mean, as we've said, is the total of all the values divided by the number of values. So we add up all of those numbers, 23 plus 34 plus 32 plus 54 and so on and so on and so on. And if we do that on a calculator or in a spreadsheet, we'll get the answer of 1313. We then have to divide that by the number of numbers that we've added up, and you'll see that there are indeed 30 numbers there. So our mean is 1313 divided by 30, which is 43.8. I think you'll agree that's a fairly straightforward calculation to carry out. It certainly is if you've only got a small number of data items. With modern software help such as spreadsheets and statistical packages such as SSAP, this is even easier for larger amounts of data. But working by hand with many more than, well, we had 30 there, and that seemed quite a lot. If you had more than 100, it gets very difficult working with raw data. So with large amounts of data, we find it's best to work with grouped data, and we'll look at how to do that in a separate video. Because of this, you'll sometimes be asked questions that provide some summary information about the dataset rather than the original numbers. So here's an example. 120 students, quite a large number of students, took an exam, and the total score of all the students was 6,600. What was the mean score in the test? So in this example, we're not given the raw data. We're just given some summary data, and we have to work out our mean from that. So the mean is the total of all the values divided by the number of values. We've seen that before. And the total of all the values is given us in the question, 6,600. So we simply take that value, divide it by the 120 to get our answer of 55. So answering that question was fairly straightforward, and sometimes we can be a little bit fooled into thinking, well, can it really be that easy? Well, quite often it is, and it's the bits of the question that later on get a little bit more tricky. So don't think that it's too simple for you to have got the right answer. Questions may also be looking to get you to find missing values, information that's not in the question. So here's an example. The average score in a test of 100 students was 60. So that's the overall average, the mean. If the mean of the top 50 students was 72, what was the mean of the rest of the students? Notice here I'm freely interchanging the word mean with average. In common usage, the word average is often used instead of the word mean, the mathematical word mean. So how do we find the solution to this? Well, we've got to work backwards. We've got to use the information to find out what the total score of all the students was if you add it all up together. Let's have a look at how to do that. So this is working backwards from the mean that we have of 60. So the total score of all the students is 60 times the 100 students who took the test, which is 6,000. So if you added all of the scores up, you would get 6,000. The average of the top 50 students was 72. So to find out how much all of those scores added up to, we do 50 times 72, and that equals 3,600. So we can subtract those numbers one from the other to find out what the total score of the rest of the students was, and that gives us a value of 2,400. So we can then work out the average of those students by doing 2,400 divided by 50, which is the rest of the students. And that gives us an average score for the rest of the students of 48. So in order to do that calculation, we worked backwards from the information we had. We worked out what the total amount of the score would be if we added it all up, and subtracted the total score of the top 50 from that to then work forwards to get an average for the other students. Simple calculations, but if we do them in the right order, we can work out some fairly complicated things that we maybe, when we first look at the question, didn't seem to have all the information for.